Welcome to Mastering Machines, where we discover tomorrow's reality.
This past weekend, I was watching the S3 1X video of them discussing the 1X robot, humanoid robot. If you haven't watched S3, definitely watch it. They have great content. But the 1X robot is a humanoid robot that can be in the home and do regular everyday tasks, something that humans crave for when it comes to robots. But when they were interviewing some of the people associated with 1X, one of the people here that we'll take a clip to mentioned that the robots will be teleoperated and not fully automated at the launch. Let's take a look at the clip.
From day one, it sounds like it's not right to expect that Neo will just fully autonomously work for people the moment they get it for the end of time. It sounds like there's still some learning and training to do.
The way we're going to tackle this problem is basically by having human teleoperation be a stand-in for the autonomy on day one. So it'll still be useful to do chores in your house, but this is fulfilled by a human operator who's remotely controlling the robot. And you can imagine that over time, as the AI gets better and better, we're replacing small parts of the workflow of the tasks and chores with AI. Kind of like the ship of Theseus, right? Where you swap out one plank at a time, and then eventually it's a completely new ship that's powered by AI rather than humans.
When I heard him mention teleoperated by humans, I couldn't help but be completely surprised, because I thought that the robots that were going to be launched and delivered to customers were going to be fully automated, not teleoperated by somebody in some, other country seeing things in your house. Let's first talk about what exactly is teleoperation and how it relates to robots and what's kind of the background of it. Simply put, teleoperation is the ability to control a robot remotely, often in real time. This isn't just pushing buttons on a control panel. We're talking about really advanced and immersive systems that allow human operators to see through the robot's eyes and control it from a country away or thousands of miles away as the movements were the robot itself. While researching for this video, I came across a pretty interesting system called Open Television that was developed by MIT and University of California, San Diego. This particular research and development is basically the next level of teleoperation. It works in multiple steps. First, the operator wears a special headset that provides a stereoscopic view of the robot's surroundings, so it can get a sense of spatially what the robot is doing, what it's walking around, and what it's seeing. Then the system tracks the operator's arm and hand movements, mirroring them on the robot in real time. So hopefully you don't see a lag due to connection or anything like that, but you can see what's happening and what's happening with the limbs and arm movements of the actual robot and what they're doing. And then the last step is that it creates an incredibly immersive experience. So basically it's almost like the operator's mind has been transported into the robot's body, and they're able to see everything spatially around them and have some sense of depth of what's happening and what the robot is actually doing. One of the most popular companies that teleoperation has been mentioned with has been Tesla. While they're working on the Optimus robot and expanding the robotics world, they're also exploring a unique form of teleoperation for training purposes. And Tesla is actually hiring people to wear motion capture suits and VR headsets to help train their Optimus robots. You can kind of think of it similar to how they use with video games and getting motion capture, but instead of this, they're getting the raw data to use with robots. Workers wear special suits and perform various tasks. Then the robots observe and mimic these movements. And then this data is used to train the AI controlling the robots, and they expand this database out so the robot gets smarter and smarter through these movements that are done by the humans in the kind of motion capture suits here. Most teleoperation typically involves, these components, which is the robot or machine being controlled, and then a human operator and the control interface that connects the two. While teleoperation hasn't hit every sector or industry, there are a couple of industries where it's really made an impact. One being healthcare, which enables remote surgeries and medical procedures from doctors and surgeons. So imagine you have to have a really important surgery done, and then the talent level or maybe the specific niche of surgeon that you need for your surgery is not available in your local area. you can have a robot do that procedure, and basically the surgeon is controlling that robot from 1,000 miles away or remotely, having the same or similar precision as the surgeon being right there physically with you in the surgery room. Then there is the use case for space or exploration, which has been used for quite some time, probably over 30 years. And this is basically using it for rovers and robots to collect samples and basically doing what human astronauts are not physically capable of doing. A positive and useful use case for teleoperation that has been really working here, especially in America and some of South America, has been disaster response, and basically using that teleoperation to have rescue robots rescue people from dangerous environments or climate situations where humans are just not able to get to them, and they're able to rescue these people. When it comes to industries that have really been using teleoperation for quite some time as well, as manufacturing and deep sea exploration. Obviously, manufacturing is one of the biggest use cases for just robots and robotics in general. For manufacturing, robots allow workers to basically have a 10x productivity output while doing it probably in half the time. And I think it's one of the biggest use cases for, all of this teleoperation is using it in manufacturing. You've seen it with cars, other heavy machinery, construction materials, even geological materials like diamonds and rocks, where they're able to have somebody operating one of those robots or robotic machines carrying these heavy loads. Also, teleoperation has been huge for deep sea drilling and deep sea exploration. Most of these areas where they're working in have not been explored previously, or they have some type of dangerous work associated with them. So in this use case, teleoperation allows, expert workers to, cut cords that are deep underwater when it comes to, underwater drilling, or even control a deep sea device that allows them to explore the ocean bed where no human can go physically. So it's really useful and really allows for us to expand the capability of what humanity can do and the output of the work. But teleoperation isn't without its challenges. One of the biggest hurdles has been latency, that a delay between an operator's action and the robot's response. Even a fraction of a second can make a big difference, especially in applications requiring precise movements like a surgery. Researchers and engineers have been working tirelessly to overcome these challenges. Some recent advancements include improved haptic feedback systems that allow operators to feel what the robot is touching. And this is great specifically for surgeries and even something like underwater drilling, where you can actually, feel the force that maybe the robot is feeling. Then you have the AI assisted control system that can compensate for latency and predict operator intentions. Then there's the virtual reality interfaces that provide a more immersive experience that I talked about earlier. And then also a big game changer that I've read about when it comes to teleoperation and when it made a huge shift is when 5G and more advanced networking technologies were implemented to basically reduce the latency in long distance operations. Some real world examples of teleoperation include the Da Vinci surgical system that allows, surgery from robots. NASA's Mars rover that allowed teleoperation on Mars and allowed them to collect samples where humans were unable to go. And then also there's the Fukushima Daiichi nuclear disaster in Japan that highlighted the importance of teleoperated robots in hazardous environments. So that goes back to my last point of using teleoperation for these disaster zones and regions affected by hazardous weather. When it comes to consumer robots and robots that will be in the home, one of the biggest issues has been privacy. And I think that that's going to be one of the major features that will need to be taken care of by these larger robotic companies like Figure.io and 1X, is to find some type of system that protects the privacy of their users while providing a great service with the robot. And I think that's going to be a lot harder than people imagine. And it will probably take a couple of generations of these consumer robots before they actually get it right. What do you think about robots in the home and teleoperation just in general? Remember, this has been Mastering Machines. Discover tomorrow's reality.